Okay, this is Precalculus. We're on page 779, chapter 12, lesson 1. All right, solving systems of equations. All right, we already talked about this, so I'm going to review real quick. If I have 3 equations and each equation has 2 variables, we call that system of equations a 3 by 2. Okay? If I have 3 equations with 3 variables, we call that a 3 by 3 in the matrix system. We're getting to matrices, okay? If I have 2 equations with 3 variables, which makes no sense, I'll tell you why in a minute, we would call that a 2 by 3. So if I say a 3 by 3, the first number represents how many equations I have. The second number represents how many variables I have. But in order to solve a system of equations, the number of variables drives how many equations I must have to be able to solve that. So if I have 2 variables, I have to have 2 equations. If I have 3 variables, I have to have 3 equations. 4 variables, 4 equations. All right, so then we talked about how do we solve a system of equations. And we've solved them by using substitution and elimination. And what we're solving for is that point of concurrency where those equations intersect, where the equations have the exact same coordinates, okay? All right, so now we're picking up on some terms that we talked about in Algebra 2. The words consistent and dependent. All right, hang with me. The word consistent means there is at least one solution in common for that system of equations. There could be more than one. They could have every solution in common. But consistent, that word consistent means at least one. Dependent, on the other hand, means they have every solution in common. All right?
Would that be the 2 lines on top of it?
Yes, yes. Okay, that's exactly right. So inconsistent, what would inconsistent mean? If consistent means at least one solution in common, then what does inconsistent mean?
None.
No solutions in common. That's right. If dependent means every solution in common, then what does independent mean?
No solution. Almost said only one.
Anything less than everything, which would be 1 or 2, depends on, but with lines, there's going to be 1 or none. Got it? All right, so if I have lines that intersect like this, what do we know? We know they have different slopes and different y-intercepts. And what would we call these equations that intersect at just one point? What would we call them? Consistent or inconsistent?
Consistent.
We would call this consistent and independent because it's less than all. Got it?
Can they be both consistent and dependent?
We're gonna talk about that in a minute. Okay. What if I have parallel lines? Hey guys, what do you know about the slopes?
The same.
Same slope, the exact same slope. What about their y-intercepts?
They're up. Oh, no.
They're different.
They're just different because if they're perpendicular, they have reciprocal
Slopes.
slopes.
Yeah. Same slope, different y-intercept. All right. Would we call this system of equations consistent or inconsistent?
Inconsistent.
Say that.
Inconsistent.
inconsistent, and what? Consistent and independent.
So parallel lines are the only ones that will never cross, right?
Parallel lines never intersect.
They're the ones
Yes.
that will never be consistent. Because they're never.
Parallel lines both have ends, knots in them.
Oh.
Got it? All right. Now, what if it's this line and then this line? What do they have slope-wise?
Same.
Same slope. What else is the same?
All of this.
Same y-intercept.
So they're consistent dependent.
So they are consistent and dependent. I want to clue you in on something. If you go to use substitution or elimination, we can know which one it is. All right. For consistent and independent, you're going to get x equals a number. You're going to substitute that back in, and you're going to get y equals a number. That's all we did last year. For inconsistent and independent, when you go to use substitution or elimination, you're going to end with an illogical statement, something like 0 equals 6. It's going to be illogical when you use substitution or elimination. And when we get to a matrix, okay, I'm just going to cue you in on this. When you get to a matrix, okay, you're going to have something like 1, 0, 6, 0, 0, 5. This, they have all zeros and your last number is a number. This makes it illogical. This tells you it's inconsistent and independent. Okay, I'm just saying this early, so when we get to it, I'm going to say, remember, I like you to hear things more often than not, okay? If they are consistent and dependent, you're going to get 0 equals 0 when you use substitution or elimination. Or when we get to matrices, your whole bottom row is going to be zeros.
And it's impossible for it to be inconsistent and independent.
It is not possible for it to be inconsistent and dependent. Correct. Okay. So this is going to be so easy walking through these examples because it's just substitution and elimination. It says do it in your calculator. We're not, because we are smart people and we can do this. Example 1, which is exactly like example 2, but they do one with their calculator and one with their brains. We're going to use our brains. All right, so all right, given these equations, I need to write in black. Given these equations, 2x minus y equals 1 and 3x plus 2y equals 12, solve. Well, I would use elimination. I would make this a 2 and eliminate y. See that?
Yes.
So I'm going to multiply this entire equation by 2 and write it down below it. You have to multiply by every term. So we end up with 4x minus 2y equals 2. And now we'll add these two equations. The y's eliminate, and I have 7x is 14, x is 2. All right, so this is consistent and independent because I'm coming up with one solution. 2, because I'm going to be able to substitute 2 back in here and solve for a y. So 2 times 2 minus y equals 1. I'm going to swap the y and the 1 so that that's 4 minus 1 equals y. Y equals 3. And I can put it back in this other equation. 6 plus 6 equals 12. And no, I have the right answer.
Interesting.
All right, so this is how you know equations are consistent and independent. You come up with one solution. You know that they intersect at just one point. You know they have different slopes and different y-intercepts. Most likely different y-intercepts. Okay, you could have the same y-intercept if that's where they intercept. That's the only way you could have the same y-intercept. All right, makes sense so far?
Yes, ma'am.
We just did example 3 as well. Now we're going to go to we just did example 2, so we're going to jump to example 3. It specifically wants us to use substitution. Y'all know that's not my favorite, but we're going to do it. 3x minus y equals 12. 2x plus 3y equals 2. How would I use substitution?
Switch the y and the 12.
Yeah, take this one, make it y equals. All right, so this is y equals 3x minus 12. I'm going to put this in that other equation where y is. Substitute it. Should use the language of math. Substitution, not put in. All right, so 2x plus 3, I'm substituting for y. 3x minus 12 equals 12. 2.
What?
2. I almost blundered, didn't I? I would have gotten the totally strange answers, I'm sure. All right, we'll distribute that 3. So we have 2x plus 9x minus 36 equals 2. I'll move the 36 to the other side through addition. So plus 36. So it equals 38. And that's 11x equals 38. Is x really a fraction
Yes, ma'am.
for number 3?
Yes, ma'am.
Oh, goodness. X is 38 elevenths. All right, I'm going back to this first equation to solve for y. In fact, I'm going to use this one. 3 times 38 elevenths minus 12 equals y. I'm just going to say what y equals, because y'all can do that math. Y equals negative 18 elevenths.
Negative.
So it's consistent.
Oh.
I just took the answer from the book. Leave it as a fraction, okay? Example 4 is elimination. Are we rocking through this? None of this is new, right?
So those are that one was consistent and independent.
Yes. All of these are, actually.
Oh.
I do believe. All right, look at example 4. X minus 3y equals 4. 2x plus y equals 1. Here they want us to use elimination. All right. So what do y'all want to eliminate, x or y?
X.
You want to eliminate x? Okay, so I'll multiply this first one by negative 2. Alright, so we have negative 2x plus 6y is negative 8. Y'all catch me if I... Our x's eliminate. We have 7y is negative 7. Y is negative 1. I'm going to substitute that back into that second equation to solve for x. And that would be 2x minus 1 equals 1. I'm going to move the 1 over. 2x equals 2, x equals 1. My point of consistency is 1, negative 1, but they are independent. All right, now we're going to talk about dependent and inconsistent.
Oh no.
Okay? It's okay. We're going to work them.
Wait, how could they have every solution in common, but not one solution?
They're dependent and consistent.
Oh, I thought you said and. You said and.
We're going to talk about inconsistent first, and then we're going to talk about dependent.
Okay.
Two separate. Yeah. Got it? All right. All right, look at example 5. It says use elimination. All right, what do you want to use? Substitution or elimination? Mike, what you want to use? Substitution or elimination?
Elimination.
Thank you. What do you want to eliminate, x or y?
Let's eliminate y.
Y? It's
Wait.
okay.
Oh, wait. No.
Yes, you can. All right, we'll eliminate y by multiplying by negative 2.
So if we multiply by negative 2. No.
Negative 2. Got it? Hey, everybody focus here.
Oh, no.
That's negative 4x plus 6y equals negative 10.
They're parallel.
It's going to be 0.
It's illogical. When it's illogical, they're parallel. They have no solutions in common. They're inconsistent
And they're independent.
and independent. Got it? Inconsistent and independent.
And they're parallel.
And they're parallel. Got it? All right. Now, look at the next one. 2x minus 4y equals 6. Negative 3x plus 6y is negative 9. All right. We want to use, Beckett, you want to use substitution or elimination? Okay. Do you want to eliminate x or y? Okay. We'll eliminate y. So I want to make y 12. That's the least common multiple. So 3 and this one by 2. Alright. So we have 6x minus 12y equals 18. Y'all be checking my multiplication here. That's negative 6x plus 12y equals negative 18.
They're the same.
So
They're the exact same line.
they are consistent, dependent.
Consistent and dependent. Okay, here's one thing I want you to note. They often ask this on the ACT. Does this system of equations have no solutions, one solution, or infinite solutions?
That's what they do ask.
This is none. This is infinite.
They also ask, or does it have two
Yeah.
solutions as well?
it could have two solutions. You're going to have two solutions if you have a second degree equation and a first degree. So a parabola, and a line. A circle and a line. A hyperbola and a line.
Those are.
One is a first degree, one is a second degree. You're going to have 4 if both are second degree, like an ellipse and a hyperbola. You can have 4 solutions when both are second degrees. We did that in Algebra 2. Okay, we also did example 7. Now I have 3 equations and 3 variables. I have to eliminate one of the variables by using all 3 equations and end up with 2 equations, 2 variables. So I need to make the 3 by 3 down to a 2 by 2. Using all 3 equations. Y'all, this is the same exact thing we're going to do when we have it in matrix form. Okay. Look at these equations. 2x plus y minus z is -1. Negative x minus 3y plus z is 5. And x plus 4y minus 2z is -10.
So we can add the first two and eliminate z.
Okay, if I eliminate z by adding the first 2, then I have to take the third one and one of these 2 to also eliminate z. You have to use all 3 equations in your first 2 eliminations. All right, so I can take the first 2 equations and I end with x minus 2y equals 4. I've eliminated z. Now, I think I want to use these 2 to eliminate z. I have to eliminate the same one. But I'm going to do that by multiplying this one by 2. Got it? So we end up with negative 2x minus 6y plus 2z equals 10. And that's negative x minus 2y equals 0. So now I have 2 equations, 2 variables. Got it? Had to use all 3 equations to eliminate the same variable. I did the first 2 and I did the second 2. Yes?
Are you always going to eliminate z?
No. I could have eliminated x. I could have eliminated x.
But then it's not going to be equals if you get.
What?
If you get like z equals number and y equals number, then you're not. Gonna
Yeah, it will still come out with the exact same answer. All right, now I'm just gonna eliminate x. Got it? So that I have negative 4y equals 4, y is -1. Remember we wrote these x, y, z, that's -1. All right, so I have y. Now I'm going backwards. I'll go here and solve for x. So I have x minus 2 times -1 is 4. That's positive 2. That's x plus 2 equals 4. When I subtract 2, x is 2. Now I have 2 of them. I have to go back to one of the 3 original equations. Here's the 3 original equations.
What did you write under the first, the 3 original ones? Under them? Yeah.
Times 2. I multiplied the middle one times 2. 2, 6, 2, 10. All right, I'm solving for z. I'm going to go to the middle one because z is by itself. All right, so the middle one says the opposite of 2 minus 3 times negative 1 plus z equals 5. That's negative 2 plus 3 plus z equals 5. This is 1, so I subtract 1, and z is 4. Can I know if my answer's right? Yes. Yes, I can. I go back to the original. Do the math with me. 2 times 2 is 4. 4 minus 1 is 3. 3 minus 4 is negative 1. It works. Here. We know it works here. I just substituted them in. We know it works here. All right. 2 minus 4 is negative 2, right? Negative 2 minus 8 is negative 10. It works in all three. Got it? All right, we'll stop after example 8. Okay, so let's go to example 8. It's a word problem. It says a ball game is attended by 575 people, and total ticket sales are $2,575. All right, so somehow I have to take the number of people times the cost of a ticket to get to $2,575. If tickets cost $5 for adults and $3 for children, how many adults, how many children attended the game? All right, what are going to be my equations?
X plus Y equals 575.
Okay, I'd actually do A plus C just because then I got to remember,
See to do.
does X mean an adult or a child? Like I got to remember that.
Oh yeah.
So
5.
I don't want to have to write that down. I want to write A plus C
So 5A
equals,
3C equals 2575.
yes. And 5A plus 3C is 2575. All right, what do y'all want to do? Substitution or elimination? I love elimination. What do you want to eliminate? A or C?
C.
C. All right, multiply this by negative 3. Negative 3A minus 3C is, what's 3 times
1,725.
1525?
Yes.
Negative 1525.
17.
1725. Okay. Our C's eliminate. I have 2A equals, what is that? 0, 5, 8.
Yes, ma'am.
Divide that by 2. The number of adults is 425 adults. Now I can figure out the number of children. The number of children is 575 minus that 150.
Yes, ma'am.
All right, somebody do the math. What's 5 times 425 plus 3 times 150? Make sure we're at 2575. 5 times 425 plus 3 times 150. It's 2575. Excellent. All right.